Now let us see memory read operation. Let us suppose the microprocessor would like to perform the memory read operation. We are not considering the opcode fetching operation. We are simply concentrating on the memory read operation. Okay, we are simply concentrating on the memory read operation. Okay, so here in the memory read signal, uh, before this, what you do is just recollect the information related to the microcomputer. No, I'm not interested to go back to that one. Okay, I'll take a slide over here. Slide over here. So here I'm just drawing a simple diagram for microcomputer. So when you would like to perform the memory read operation, from when the microprocessor would like to perform the memory read operation, it is an MP. Okay, microprocessor MP, and it is a memory. I'm just taking the MEM for this. I'm just taking the MEM. Okay, it is a memory. Okay, when the microprocessor would like to perform the memory read operation, means when the microprocessor perform the read operation, first what it is doing, I think I would have given the points. First it is placing the address on the address bus. First it is placing the step one it is placing the yeah, sorry, it's taking the to perform the memory read operation. I hope already given this information during the microcomputer explanation. Read operation. So when the microprocessor would like to perform the read operation, what are the steps it is performing? Okay. Number one, first it is placing the places address on address bus. Places address on address bus. Sorry. Address on address bus. After that, step 2. After placing the address on the address bus, it will generate the read signal. Okay, now generates read signal to memory, generates the read signal to the memory, and the memory is the one which is placing the data on the data bus, and the microprocessor is going to read that data. Okay, memory places the data on data bus. I'm just using the D/B, as all of you know. I'm just using the shortcut. Places the data on the data bus, and microprocessor reads the data from the bus. Microprocessor reads the data from the bus. So these are the three steps which are going to be followed by the microprocessor to perform the read operation. Okay. So now first what it is doing, it is placing the address, means from which memory location microprocessor would like to read the information. That address is going to be placed on the address bus. Means whatever the address lines which we are having, those address, that is the multiplex lines are there na. We are having the multiplex lines na, that is nothing but AD 02, AD02, AD15, and A16 slash S32, A16 slash S32, A19 slash S6. Okay, these are the multiplexer signals now. These signals during the first step, means when the microprocessor would like to perform the read operation, these signals should act as a address lines, because the first step which is followed by the microprocessor is placing the address on the address bus. Means these are the multiplex lines which are acting as the address lines, as well as the data lines, as well as the signal lines. These multiplex lines should act as the address lines. Okay, should act as a address lines. After that, the microprocessor is generating the read signal. After that, these lines should be immediately converted into the data lines. These lines should be immediately converted into the data lines to perform the read operation, because in order to carry the data from the data bus, from the memory into the microprocessor, these lines should converted back into the data lines. These lines should be converted back into the data lines. All these things we are going to see in the signal status format. All these things we are going to see in the signal status format. Okay, so yeah, look at this one. So in order to perform the memory read operation, it is taking the 4 clock cycles. To perform the memory write operation, it is taking the 4 clock cycles. For the IO read, IO write also same thing. So let us focus on how exactly the microprocessor is performing the read operation. As I said, in order to convert the multiplex lines, address signals and the data lines, in order to convert the multiplex lines into the address bus, we are having one signal, controlling signal called as a ALE signal, address latch enable signal. This ALE signal is going to be takes the responsibility to demultiplex the multiplex lines. So as I told you that during the first clock cycle of our operation, during the explanation of the pin diagram, I told you that point. During the first clock cycle of our operation, that may be the fetching operation, that may be the memory read operation or memory write operation, the ALE is going to be the active high. When the ALE is active high, when the ALE is equals to the 1, at that time, these lines are converted into the address lines. Okay. So these lines are converted into the address lines. So if you want, you can see that one. So I'm just drawing one block. Okay, one square bracket. Look at this one. During this time, the lines are acting as a address lines. During this time, the lines are acting as a address lines. Okay. So after T1 clock cycles, okay, now after T1 clock cycles, the ALE is converted into the means ALE signal status is going to be the active low. During the first clock cycle only, it is in the active high position. During that time, these signals are converted into the address lines format. So during the second clock cycle to the fourth clock cycle, during the second clock cycle to the fourth clock cycle, the ALE is going to be the active low signal. The ALE is going to be the active low signal. So during the first clock cycle, it is the active high, and from the second clock cycle onwards, it is going to be the active low signal. It is going to be the active low signal. Okay, means the address lines, whatever the address lines are which are there, whatever the multiplex lines are there, those signals are acting as the address lines for some period of time. And once the ALE becomes a 0, it is taking some time now. During the once the ALE becomes 0, immediately these lines are acting as a data lines. These lines are acting as a data lines. Okay, so A19 to A16 are multiplexed with the signal status now. So we are having the signals line signals over here. AD15 to AD0 are there now. They are acting as address lines over here and as a data lines over here from that T2 to T3 time period. From the T2 to T3 time period. Okay, as I told you that the microprocessor, when microprocessor would like to perform the read operation, first it will place the address on the address bus. So that's why during the first clock cycle, it is going to be the address bus. After that, it is generating. If you concentrate on this one, these lines are converted into the data lines, but between these two status, the read signal is active low. Okay, so when the read signal is active low, the memory device is the one. See, don't think that when the microprocessor would like to perform the read operation, don't ever think that the microprocessor is going to be literally entering into the memory and reading the information means reading the information means it is not entering into the memory device and picking the value from the memory location. Actually, it is not doing like that. The microprocessor simply generates the address line, simply places the address on the address bus, generates the control signal, that is a read signal. So it is the responsibility of the memory device to identify the location of the address and take that value, place that value on the data bus within some period of time, within the predefined period of time. Within some period of time means don't think that it is going to be take the 2 seconds, 3 seconds, 1 minute, 2 minutes like that. It is not like that. There is a prefixed time delay. Within that time, the memory device is going to be places the data on the data bus. Okay, so if you see this one, soon after ALE is equals to the 1, it is in the address status. These lines are acting as address lines. After the ALE becomes a active low signal, then these lines are converted into the data lines. But the valid data is there on the data bus only when we are having the read signal. Now you may ask me one question, sir. When we are having the read operation, within the first period of the means during the starting period of the read signal, why we are not having the valid data? Because this is a time taken by the memory device to identify the location within it inside the memory and picking that value, placing that value on the data bus. For that, it is going to take some time. So that's why the read signal should be active low from some for some period of time. It should be active low for some period of time, so that the that is a memory device realize the location, picks the value, places the data on the data bus. So if you see, if you divide this duration into two parts, if you divide this duration into two parts from the RD bar signal, within the first one, the microprocessor is trying to read the information. The memory device realizing that it need to perform the read operation, and it is picking the value. And in the next time duration, means after some period of the read signal, during this period, it is placing the data on the data bus. During this period, it is placing the data on the data bus. Now the data is now the data bus is having the valid information. Okay. So if you see this one, read signal is playing a major role. So remember, again I am repeating the explanation. When the microprocessor would like to perform the read operation, first it is placing the address on the address bus, generates the read signal. First it is placing the address on the address bus. So during this period, during the ALE equals to the 1, it is these lines are acting as address lines. At that time, it is placing the address on the address bus. After some period of time, it is generating the read signal. Once the memory device receives the read signal from the microprocessor, it is going to be reads the value from the specified address line and places the data on the data bus. So it places the data on the data bus. So after this period of time, means again it is a prefixed time period. The read signal period is a prefixed time period. So after this time period, so means within this time period, the microprocessor realizes that there is a valid data on the data bus, and it is going to read the data from the data bus. Okay. So this is about the RD bar signal. So means RD bar signal is not going to be active low during the first clock cycle of the machine cycle. That is nothing but the memory reader. For the memory read operation, we are having the 4 clock cycles now. So within the first clock cycle of these 4 clock cycle, read signal is not active low. Just concentrate on that. You simply focus on the concept. Okay, now concept is nothing but first it places the address on the address bus, generates the read signal, reads the data. So in order to place the address on the address bus, address line should act as that is a multiplex line should act as address lines now. For that, ALE should be active low, active high. So that's why during the first clock period it is in the active high, and the read signal is in the active high position, because in order to deactivate the operation. So after that, during this period, these lines are carrying the address information. After some period, the microprocessor is generating the read signal. So within the read signal status, the memory device reads the information from the location and places that information on the data bus. So data in from the memory places the data on the data bus. Once the data is placed on the data bus, the microprocessor reads the data from the data bus. Okay. So this is the read signal status. Okay. So now the another thing is DT slash R bar. Now we are having one more pin called as a DT slash R bar in the microprocessor case. So DT slash R bar is nothing but data transmission and receiving signal. So what kind of operation we are performing over here? We are reading the data from the memory into the microprocessor. We are reading the data from the memory into the microprocessor. As I said, DT slash R bar is indicating the direction of the data flow. DT slash R bar is indicating the direction of the data flow. So reading operation means we are reading the data from the memory into the microprocessor. Na? So that's why it is showing this as we are reading the information from the memory into the microprocessor. So that's why it is showing the signal status as a receiving. Receiving means microprocessor is receiving the data. So receiving is the active low. Na? So that's why during the entire period of the memory read cycle, during this entire period of the memory read cycle, the DT slash R bar is in the active low signal status. It is in the active low format. Okay. Now. So as I told you that if at all the what is that in order to enable the data bus buffers which are there in the external, we are going to define the buffers also. Don't worry about it. As we move on, we are going to see that one. In order to enable the buffers, we are having a concept called as a buffer. So buffers, we are having the DEN bar. So that is going to be activated just before starting the read signal, and after finishing it is going to be terminated after finishing the read signal. Just before read signal and after finishing the read signal, the DEN bar is going to be activated. Okay. So let us suppose I would like to perform the write operation. When you would like to perform the write operation, same concept. When you would like to perform the write operation, same concept is there. During the first clock cycle, again the ALE is going to be 1, and these lines are acting as the address lines. So in order to perform the write operation into the into the memory device by the microprocessor, the concept is little bit different. Okay, now so to perform the right operation, what are the steps which are going to be followed by the microprocessor is a question. Okay, to perform the right operation, right? Okay, what are the steps which are going to be followed by the microprocessor? Number one, first, as usual, places the address on address bus. As usual, places the address on the address bus. Now, previously we are having the generates the read signal, na? But here, along with the address, it is go after some period, means after the first clock cycle period, we will place the data on the data bus. Place the data on data bus. Place the data on data bus. Okay. After placing the data on data bus, it will generate the write signal. Third step is going to be the write signal. Okay. Okay, write signal. Generates the write signal. Generates the write signal to the memory device. Means when the microprocessor would like to perform the write operation, these three steps which are going to be followed by the microprocessor. To perform the write operation. First places the address on the address bus. After that, after some period of time, places the data on the data bus. After that, it will generate the write signal. At that time, when the memory device receives the write signal, it realizes that there is a valid data on the data bus, and it will read the information from the data bus into the memory device. Okay, now. So one more point, that if you want to realize this concept, you just recollect the information related to the microcomputer organization. We have seen the microcomputer now. So during that explanation, I have given the detailed explanation. You just follow that video. If you are not getting this one, you just follow that video once again. Okay. So the next. So as I said, when the microprocessor would like to perform the write operation, as usual, during the first clock cycle, AL equals to the 1, and these lines are acting as address lines. Immediately these lines are converted into the data lines, because the AL is going to be active low. Immediately they are converted into the data lines now. So valid data is placed by the microprocessor on the data bus, and in the end, so valid data is going to be placed on the data bus. So once the data is placed on the data bus, microprocessor takes the responsibility to generate the write signal. So during the write operation, the information is going to be transferred from the microprocessor to the memory device. Okay, now. So this is a signal status. Now, if you see the DEN, again, don't get confused. DEN is the active low. In the read operation case, DEN is the active low at the end of the memory read operation. During the memory write operation, it is going to be active low after first clock period, after first clock cycle. So regarding this DEN, don't get confused. This one purely depends on the at what time the multiplex lines are acting as a data lines. At that time only this is going to be activated. Okay. So if you see this one, during the data lines case, DEN is going to be active low. During the data lines case, DEN is going to be active low. Okay. So don't worry about it. We are going to see the multiplexing the signals. Okay. So another signal status is a read signal na. So sorry, DT/R bar na. So here we are performing the write operation, means information is transferred from the microprocessor to the memory. So the signal status is a active high, means we are performing the transmitting operation. Microprocessor is indicating that it is performing. DT/R bar is used for indicating the direction of the data flow. Simple case. So it is showing the data is coming out from the microprocessor to the peripheral device, that may be the memory device. Okay. So this is about the bus cycles in our means some of the signal status when the microprocessor would like to perform the read operation and the write operation. So if you want to realize this entire signal status concept, you simply realize what are the steps which are followed by the microprocessor to perform the read operation. As I said in the previous video, that is nothing but first it is placing the data on the data. First it is placing the address on the address bus, generates the read signal, and the memory device is placing the data on the data bus, so that the microprocessor is going to read the information. Okay. And when the microprocessor would like to perform the write operation, first it places the address on the address bus. After some period, it places the data on the data bus and generates the write signal. Okay. Now, these are the three steps followed by the microprocessor. Again, remember that when the read signal is active low, when it is performing the read operation, the write operation is going to be in the active high status. Write operation is there in the active high status. Okay, now remember that one. So when you are performing the write operation, then the read signal is in the active high mode. Read signal is in the active high mode. It is only for realizing exactly how the signals are going to be changes. It's their status depending on the type of the operation, but nothing to do with this in the exam. But in the exam they may ask you about what exactly that define the bus cycle or define the instruction cycle. There is a difference between the bus cycle and the instruction cycle. Bus cycle is nothing but either read operation, write operation with respect to the memory or the IO. But instruction cycle is nothing but it includes all the things, means fetching operation, the time taken by the microprocessor to perform the fetch as well as the execution. The time taken by the microprocessor to perform the fetch as well as the execution is called as an instruction cycle. Don't get confused with that. Okay, so this is about your bus cycles concept in our 8086 microprocessor. Next case is when you would like to when you would like to design a system using the 8086 microprocessor or any kind of microprocessor. As we have seen in the pin diagram of microprocessor that if you want to get the functionality from the microprocessor, we are supposed to provide the required amount of clock signals with the help of the clock pin, which is a, I think if I'm not wrong, it is a 19th pin. So with the help of the 19th pin, we are providing the clock signal to the microprocessor with the help of the 19th pin. Yeah, I think let us go back to the pin diagram. I'm sure about it. Yeah, yeah. With the help of the 19th pin, we are providing the clock signals required by the microprocessor. Okay, we are providing the clock signals required by the microprocessor. Now, the next concept as per your syllabus, if you are go through the syllabus, the next concept is going to be the basic system components. Next is topic subheading is going to be basic system components. Basic system components means when you would like to design one system using the microprocessor, you can't design the system only with the microprocessor. You are having some components. You require some components. So without those components, external components which are interfaced to the microprocessor, without those components you can't establish the entire system. Okay, so what are the basic systems which are going to be mandatory in designing the microprocessor basic system is a question. So if you want consider the first point, which is nothing but the clock generator. The first basic system component is a clock generator. Okay, so first basic system component is a clock generator. Okay, clock generator. The first one is a clock generator. As per our syllabus, we are moving clock generator. So the main intention of the clock generator, the IC number for this particular clock generator is a 8284. 8284 is a clock generator which is used in a microprocessor based system, that is a 8086 microprocessor, to provide the required amount of clock signals. This 8284 is not only providing the CLK clock signals required by the microprocessor, it is also providing the reset signal and ready signal. And along with this, we are having one more thing also, which is a peripheral clock. So means these are the few signals which are coming as an output signal from the clock generator. These are the 4 signals which are coming as an output signals from the clock generator. Means with the help of the 8284, we are going to provide the clock signals to the 8086 microprocessor, and it is also providing the reset signal. Reset signal means with the help of the 8284 we can generate the reset signal to the microprocessor to reset the activities of the microprocessor, and with the help of the ready signal which is coming from the 8284, we using this particular signal we can provide the required amount of delay to the microprocessor, so that in order to check it out the readiness of the peripheral device. We have seen the ready signal in 8086 microprocessor. So 8086 microprocessor ready signal is the input signal, and this one is the output signal coming from the 8284. We are going to see that one in detail. Peripheral clock signals. These are the 4 different types of clocks, different types of output signals which are coming from the 8284. So under the basic system components concept, we are going to study the 8284, which is nothing but the clock generator. Let us see the internal block diagram of the clock generator. Okay, so this is the internal block diagram of clock generator. internal block diagram of clock generator. This side are the inputs to the clock generator, and this side is the output from the clock generator. This one is the input to the clock generator, this one is the output to the clock generator, and it is the internal block diagram of, sorry, it is the internal block diagram of 8284. It is the internal block diagram of 8284, which we are going to study in the next video, which we are going to study in the next video. Okay now, so 8284 is nothing but it is a clock generator, which is used for providing the different signals required by the microprocessor. One may be the reset signal, another one is a what is that, clock signal, another one is a ready signal. We are having the PCLK. PCLK is nothing but the peripheral clock. There are some peripherals which are expecting the clock signals, and if at all this frequency, whatever the frequency which is coming from this particular line, if this one is sufficient to the peripheral device, then we are going to make use of this signal as a peripheral clock to the peripheral device. Okay, which we are going to see in the next video. Okay, so that's all for today's class. We'll continue in the next class with 8284.